So I just want you to look at this, okay? It's already worked out. If I start here, so let's say that this is problem number 1, right? And I'm going to solve it. Then I have these logs, so I condense them to this, right? Because that's becomes multiplication. I distribute that, I get this. I have log base 5 on both sides, so now it becomes this right here, right? And then I can set it equal to 0, and I can factor it. If this is problem number 2 starts like this. So it actually starts at this step of problem number 1. You see how those are the same? Okay. This is my starting point in number 1. This is my starting point in number 2. So the work ends up being the same, and I get to the same point right here, right? And then when I go to figure out what my results are from here, in both of them I get -5, 4, -5, 4. So those are the same in both. But then I have to check my answers, right? And so when I plug in this, when I substitute in the -5 right here, can I take the log of a negative number? No. So this one doesn't work. This one right here is extraneous. Right? When I take the -5 over here and I substitute it in, is it going to work? Yes, because -5 squared is positive 25, then plus -5 is still a positive 20. So here, it's not an extraneous answer. So what my question was that I couldn't get answered for a couple of days no matter who I asked was, if these are truly equal, when you look at your condensing and expanding rules, then this equals this, or at least these two, right? You can multiply them. So if they're equal, then they're equal. They're the same. So why does my answers are different in the end? I really finally, after digging and digging and digging, I could kind of make sense of why I could get the answers, you know, like if I graphed it on something else and I know I know this is right, that they're different. But the why behind it is that the domain, it matters from the very beginning. So from the very beginning, that's what we look at, even though they're the same. So yes, you can expand it and condense it, but your restricted domain is still restricted. Does that make sense to you? That's why even when it is restricted, regardless of whether or not there was a strange case like this, you still get these two, but then you have to pay attention to the domain. And the domain is related to the original version of it. Does that make sense to you? So that's and I understand that I know that that's confusing, because that was something, that's why I was like, right before I came in on Friday, I was like, okay, because this was actually the question I was going to do. And then as I was thinking through it again, I was thinking, oh, well, I could expand that. And then when I expanded it, I was like, oh, dang, then that changes my answer. And I wasn't sure how to explain the why. I just knew that they were different. And but that's why. It all has to do with the domain of the original one. Makes sense? So you always have to go back to the very beginning. Everybody okay on that? Okay, good deal. All right, so now looking at the review, is there anything that stands out to you that you have a question on or that you would like to see? Anything? Gotten very far on it. Like what? Yes, ma'am. 14? Okay. 14 is a good one. All right. Yes, I will. And I'm going to start it during 4th period. I have a meeting today again after school, and so my plan was to try and start this on Friday, and that did not happen. So during 4th period, I'm going to start it. Hopefully I will get as much done as I can, but it may be not until after my meeting that I actually get to come back and finish it. But all right, so here's what I have. If 16 to the x power equals 128 times 32, the 4th root of 32. So I'm going to rewrite this as 16x to the x power equals 128 times 32 to the 1/4 power. Now, I have to decide what the base is. Now, it would be nice if I could use 4 and not 2, but can I break down the 32 into a 4 easily? Like 4 doesn't divide, well, 4 divides in there, but it's not a root of it, so I can't do that. So I'm going to have to go with 2, right? So if I break these up, 16 to the x power, what would 2 be? 2 to the what? 4th. So this is 2 to the 4x equals, okay, 128 can become 2 to the what? 7th. And then 32 can become 2 to the 5th. Yeah, 5 times 1/4, so yeah. So then be 5 over 4. Because it is 2 to the 5th, so then you have the 5 times the 1/4. Everybody okay with all that? Now, when I have this here, and these two bases are being multiplied, do I multiply these exponents? I add them. So this is 2 to the 4x power. That is equal to 2. Well, 7, I got to get a common denominator, so that would make that 28 over 4, right? So 28 plus 5 is 33. So I get 33 fourths as the exponent. Everybody good so far? And then that means now I can say that 4x equals 33 over 4. So x is going to be equal to 33 over 16. Yeah, it's really not that bad. You just have to remember that when you have the roots, you got to change them to the rational exponents and then make sure you're adding the exponents. I know you know those rules, but again, that sometimes they're just, you do weird things even though you know better. Okay. Anything else that you want to see right now that you can think of? Number 18. All right, number 18. And there's not a whole lot of room to work on these, I know. Well, and the way I first did it was weird anyway. But all right, so I've got natural log of 1 over e to the 5/4 power, or the 4/5 power, basically. So I'm going to rewrite that. The natural log of 1 over e to the 4/5 power. Oh, it doesn't look like a power, but it's power. Everybody okay with that? So you can do it one of two ways. The natural log of e is just 1, so you can adjust this, or you can go ahead and solve it like the rest of them. What is the base of a natural log? E. So if I set this equal to k, right? So the base is e, so e to the k power is equal to 1 over e to the 4/5 power. So that just means that e to the k power is equal to e to the negative 4/5 power. So the answer to that is negative 4/5. Or even at this point here, you could change that to natural log of e to the negative 4/5 power. And then since it's natural log of e, that just to this power, that just makes that your answer. Whichever way. You can work either way on that one. Why is it negative? Because it was 4/5 and it was in the denominator. So I had to make it negative to get it out of the denominator. So the bases would match. Okay? That make sense? We good? Anything else? 4? Okay. All right, so my suggestion on these sketching, okay, is that you sketch, either jot it down or have in your brain what it looks like as the parent function. So the parent function of e to the x just looks like this, right? Bam, just like that. So then once you have that parent function, then you can think about what's happening with all the rest of the stuff that's going on here. So my important point that I start with is here. When my x is negative, that's a reflection in what? The y. So when it's a reflection in the y, this point doesn't move, right? But it is going to flip around what my graph looks like. And then that negative 1, or that minus 1 right here, what happens with that? Shifts down 1. So there's where my point is. My asymptote was at y equals 0. Now it's at y equals negative 1. Okay. And this is here at 0, 0. And instead of my graph looking like this, it was a reflection on the y-axis, so it's going to come and look more like this right here. So remember for your sketches, because what some of y'all got on your homework that was not so good, was that you just kind of randomly, like if it was 3, you'd shift it up or whatever, you just like have a point up here. Well, you need to like have the little hash marks that count it off, or actually write what the numbers are. Because if I want this up here to represent 3, I need to mark it and put a 3 or put 3 hash marks so it's obvious. Okay? We okay with that? So make sure on these that your asymptotes are graphed and at least one specific point. Okay, and then the rest is just kind of thinking about what's happened with it. Okay, we good? All right, it would really, I think, be helpful to you to have, that at least in your mind. But at the same time, once you start reflecting things and shifting it, if you can always literally look at the original, that will help you. So I would suggest sketching a little tiny one there. Anything else on any of them? 11. Okay. So on here, we have to come up with some points, right? Your parent function is going to be f of x equals log base 1/3 of x. That is your parent function, right? And then I would, if it were me, different ways to do this, but if it were me, I would start with my table being of my parent function. And to be able to come up with these, if you're not sure what they are from looking at that, you can write it as an exponential, which would give you 1/3 to the y power equals x. Okay? And then you pick the points, because you can pick whatever points you want. I would pick points that would be helpful here. It would kind of make things a little bit easier maybe. But I would choose my y's, way easier than choosing x's here. I would go with -2, because I think that's something I can handle here. -1, 0, 1, and 2. Gives me an idea of what's going on. And the graph of my parent function looks something like, it's a log. I know that that's an important point. If I go this way, if b is greater than 1, it comes like this if b is a fraction. So parent function looks something like that. So when I actually use these for my parent function that I wrote as an exponential, 1/3 to the -2 power is what? 9. And then this would be 3. This would be 1. This would be 1/3 and 1/9. Right? Okay, everybody good with that? Then instead of worrying about writing this as an exponential or substituting things into here, I would use this and then figure out what's changing up here. Right? So does anything change for my y? Yeah, the sign changes, right? So this is -2. I'm going to change that to a +2. This becomes a +1. 0 is just 0. This is -1, and this is -2. And then what happens with my x? Multiply by 2, because whenever it's in there, you do the opposite of what you see. So it's 1/2 times x, which means I multiply it by 2. So this is 18. This is 6. This is 2. This is 2/3, and this is 2/9. Okay. Sorry, what? Right. When you're changing the x, you do the opposite of what that is. So you remember, if it's x plus 2, that means I shift to the left, because I actually subtract 2. When you do 1/2 times x, you're actually, instead of multiplying by 1/2, you're dividing by 1/2, which is the same as multiplying by 2. You do when it's affecting the x in there, it's the opposite of what you have. It's the inverse of what you have. Right. If that was 2x, then I would divide by 2, which is multiplying by 1/2. Yes. It's always the opposite. Then you just go plot these points. Well, that first one ended up being kind of big. It's not the end of the world. We're going to skip it for now, and I might come back and add it in there. But we'll go 1, 2, 3, 4, 5, 6, 1. And it's 2, 0. And it's 2/3 -1, and it's 2/9 -2, and then I can't extend this out here. And this goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Somewhere out here, and I would go to 2. I can go, oh, look, that's right there at 18. Which is really not even that important at this point, but it does help you with it's not worth going back and choosing another point. You know what I mean? And then your asymptote is still here at x equals 0, because there was no shifting. Everybody okay with that? Oh, I totally did. No, I did that right. I did that right. Never mind. I was like, oh, wait, that's not what it looks like, but it's because we reflected it. It threw me off. Like, oh, no, I did it wrong. But, yeah, because it had this, but it was a reflection in the x-axis. So, we good? Anything else we need to talk through? Right, because the sign changed on the y, so it's a reflection in the x-axis, yes. But see how that made me second guess myself? I was like, what? Wait. And then, so, okay, I got that right. Otherwise, I might have thought through something else all wrong. That's why it's good to have that. Anything else you can think of right now? You just want some time to work on it? Okay, you can ask me questions individually. It's all good. Just thought if there was some good discussion.